If you want to see a black hole tonight, go outside, look in the direction of Sagittarius. That's where we have the center of the galaxy, and a black hole weighing perhaps 2 to 4 million times the mass of the Sun, lurking right at the center of our own backyard.
Kaku is a renowned physicist and futurist who has authored several best-selling books on science and technology. His theory challenges our conventional understanding of the universe, suggesting that our three-dimensional universe is the projection of a hologram that is encoded on the boundary of a higher dimensional space. In today's video, we will delve into Kaku's theory, its implications for our understanding of the cosmos, and the criticisms and limitations it faces. According to the widely accepted Big Bang theory, the universe began as a singularity, a point of infinite density and gravity, which rapidly expanded in a massive explosion. However, Kaku proposes that the universe did not begin as a singularity, but rather as a higher dimensional object, a hypersphere. He argues that our three-dimensional universe is embedded within a higher dimensional space. This hypersphere, he suggests, is the equivalent of a black hole in higher dimensions. Kaku's theory is based on a concept known as the holographic principle. The holographic principle is a concept that has gained a lot of attention in recent years in the field of theoretical physics. It was first proposed in the 1990s by physicist Gerard T. Hooft and later developed by physicist Leonard Susskind and others. The principle suggests that the universe can be thought of as a hologram, where all the information is contained on the surface of a boundary surrounding a particular region of space. The idea behind the holographic principle is that the amount of information that can be contained in a region of space is limited by the surface area of its boundary, rather than its volume. This means that the information in a three-dimensional space can be encoded on a two-dimensional surface, such as the surface of a sphere. In other words, the universe could be seen as a projection of a hologram that is encoded on the boundary of a higher dimensional space. Kaku's theory takes this concept further by suggesting that our three-dimensional universe is the projection of a hologram that is encoded on the boundary of a four-dimensional hypersphere. This means that the information that makes up our universe is not contained within the space itself, but rather on the surface of the hypersphere. Kaku suggests that the universe is like a hologram in that all the information is contained on the surface, rather than in the volume of the space itself. If Kaku's theory is correct, it could have significant implications for our understanding of the universe. For one, it could explain some of the most puzzling mysteries of the cosmos, such as the nature of dark matter and dark energy.
Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang, that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen.
It could also help reconcile the theory of relativity, which describes the behavior of large objects in space, with quantum mechanics, which describes the behavior of subatomic particles. As with any scientific theory, there are criticisms and limitations to Kaku's proposal. One of the main criticisms is the lack of empirical evidence to support the theory. While there is some mathematical evidence to suggest that the universe could be a hologram, there is no direct observational evidence to support Kaku's specific hypothesis. Additionally, some experts argue that the theory violates the laws of thermodynamics and could lead to inconsistencies in our understanding of the universe. In conclusion, Michio Kaku's theory is a fascinating and mind-bending proposal that challenges our understanding of the universe. While it remains a topic of debate and further research is needed to fully understand its implications, it provides a new perspective on our place in the cosmos and the nature of reality itself. If you enjoyed this video, make sure to subscribe to our channel for more mind-bending explorations into science and technology. Thank you for watching.